What's going on, math geniuses? John, Joe, and Jimmy here, and we're going to teach you how to graph hyperbolas so that you could pass the test that your friends didn't. Let's take it over to Jimmy.
Hi, I'm Jimmy. Today you'll learn how to graph a hyperbola and label all key points. And here you can see the standard form. And for k and h, it could be both negative and positive. And we're going to learn how to convert a polynomial equation into the standard form of a hyperbola and how to use the equation to graph it and label all key points. So, we have an instructor to show you how to solve a problem about hyperbola.
So the following is a polynomial equation. Due to the fact that there is both an x squared term and a y squared term, we can tell that in standard form, this is either going to be the equation of a circle, an ellipse, or a hyperbola. However, the way to transform this into standard form for either three conic sections is very similar. You would start by creating two perfect square trinomials. So let's demonstrate this. So you would start by grouping these two terms together and these two terms together and then moving this term to the other side. And once you've done that, now you can see that there's a GCF factor in both of these two sets of terms that you can factor out. Here it is positive 9. So once you factor that out GCF style, you get x squared minus 6x minus 16 times y squared minus 4x minus 4y, sorry, that's a y. Sorry for that. And then we're going to move this to the other side, equals 127. So once we've done that, we are going to make this a perfect square trinomial by dividing b by 2, because this is the b term in a quadratic. So that's 3. Squaring that, that's 9. So we are going to add 9 right here. We are going to divide 4 by 2, because b over 2 squared, and that's 2, and then squared is 4. So we're going to add 4 over here. Now, in algebra, you always have to do to the right side exactly what you do to the left side. So we have to multiply when we are adding inside the coefficient, inside the parentheses, by the outside coefficient. So we're multiplying 9 by 9, so that's 81. And we are multiplying 4 by negative 16, so that's negative 64. So now when you rewrite this equation, this simplifies to x minus 3 squared, and this simplifies to y minus 2 squared. So what that would look like is 9 times x minus 3 squared minus 16 times y minus 2 squared equals 144. Now, the rule for a standard form of either an ellipse or a hyperbola, and since this video is about hyperbolas, you know it's a hyperbola, is that you always have to have the other side of the equation equaling 1. So we are going to divide both sides by 144, and you end up getting that 144 divided by 9 is 16, and 144 divided by 16 is 9. So what you end up getting is you end up getting x minus 3 squared divided by 16 minus y minus 2 squared divided by 9 is equal to 1. Now this is your standard form of a hyperbola because the sign of this is not the same as the sign of this. This is positive and this is negative. Okay, so now that you've just derived this equation from a polynomial, we are now going to learn how to use this equation to graph what in this case we know is a hyperbola. So we can see here that because it's x minus h squared and y minus k squared, that the center point is going to be positive 3 comma positive 2. So now we're going to plot that right here. Positive 3 comma positive 2 as an ordered pair, and then we're going to write as we go what the information that we know is. So the center point is 3 comma 2. I've done the liberty of making little tabs that have the information that we need on them. So next we can find our vertices and our co-vertices. Due to the fact that it's x minus something over something or plus something over something squared and minus y something over something squared, that's how we know that it opens up and opens down. If it was the reverse, where it was positive y over something squared minus x over something squared. So if the x was negative and the y term was positive, then it would open left and it would open right. So we also know that the graph opens up and down. So we're going to put that right there. That also tells us that the transverse axis is going to be along the y-axis and the conjugate axis is going to be the x-axis. So the vertices are always on the transverse axis. So now we know that these are going to be our vertices. How do you find your vertices, you ask? Well, you take which axis you're on. So we're on the y-axis. We're going to go over here and find that the denominator of the little fraction in the equation is a 9. If you take the positive square root of that 9, which in this case would be 3, that's the amount of units you move up and down, or in the other, if it was the x-axis, left or right, from your center point. So we're going to find our vertices by going up 1, 2, 3 units. See, we haven't really done any math yet, and we already know so much stuff. So we're going to go down 3 units, and these are our 2 vertices. So now it's a good idea to write them down. So these are our vertices. And now we're going to find our covertices. It's a very similar concept. You go to the x-axis, because that's the axis we're on. So you go to the x fraction, find the denominator, take the positive square root, which is 4, and count that many units left and right from the center point. So 1, 2, 3, 4 units. And then 1, 2, 3, 4 units. So now once we've done that, we can make a little box, which is what many people like to do once they found their vertices and their covertices. Okay, so we should probably write what the covertices are. And now what we can do is find the length of the transverse axis and the length of the conjugate axis. How do you do that, you ask? Well, it's just counting once again. So you go to the transverse axis and count. 1, 2, 3, 4, 5, 6. So therefore, you know that the transverse axis is going to be 6 units long. It's very simple. And now, the other axis, the conjugate axis, you count again. 1, 2, 3, 4, 5, 6, 7, 8. So therefore you know that the conjugate axis is going to be 8 units long. Now we have to find our asymptotes. So there's a very simple way to find the asymptotes. You take the square root of the denominator of the y, fraction. So that would be 3. And then you take the square root of the x fraction, that's 4, and you put the y over the x, so that's 3/4. So that's how you know that the slope of the asymptotes are going to be plus or minus, so plus 3/4 or minus 3/4. So let's just write that down, plus or minus 3/4 x. And where do you start on the graph? You start at your center point. So you're going to count up 3 over 4, down 3 over the other way 4, and now you're going to have your asymptote. It's a dotted line, and it goes on, so it's continuous. You're going to make an arrow, and then you have your asymptote. Now to find your other asymptote, you do the same thing. Okay, there, now you have your 2 asymptotes. Now, it becomes very, very simple to draw your graph. What do? You know that in asymptote, the graph gets very close to it, but it never actually touches. And you know that the graph has to go through each vertice. So, all you have to do is draw one line that goes really, really close but doesn't touch it, and is continuous. And then you draw another line that goes really, really close and doesn't touch it. And then you know that the graph also opens down, so you have to do the same thing on the other side. You draw a line that goes really, 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 really close to the asymptote and doesn't touch it, and you draw your arrow, and then you draw the one that goes really, 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 really close and doesn't touch it, and then you draw an arrow. So there, now you have your graph. I'm not actually going to tell you what the y-intercept would be of this equation, so we're just going to write plus b for now, because you should know how to find that yourself, and you can watch another video for possible help on that. So the one thing left to do is the foci. So to calculate the foci, it's actually an equation that might look similar to the Pythagorean theorem, and mathematically it might be the same, but it's a different concept. So it's going to be a squared, so a squared plus b squared equals c squared. And what's a, you ask? A is going to be one of the denominators squared, or the square root of one of the denominators squared, rather. And then b is going to be the square root of the other denominator squared. So it doesn't matter what order they go in because it's a plus sign and not a minus sign. For an ellipse it would matter, but that's for another video. And so the square root of 16 is 4. Square that, you're back at 16. So we're just going to write 16. And the square root of 9 is 3. Square that, you're back at 9. So plus 9 equals c squared. C squared is equal to 25. Just flip that around by the reflexive property. And if you take the square root of both sides, you get that c equals 5. So what does this tell you? It means that it's 5 units along the transverse axis from the center point. So we're going to count 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And there you have it, folks. You have all the key points. You have your foci, which now we just have to label the foci as ordered pairs. So it's going to be 3, negative 3 as one foci, so 3, negative 3 as one foci, and the other foci, semicolon there, is going to be 3, 1, 2, 3, 4, 5, 6, 7. 3, 7. And there you have it. These are the ordered pairs of your foci. So from this video, you hopefully now have a better understanding of how to convert a polynomial equation with both the x and y terms squared into the standard form equation of either a hyperbola, an ellipse, or a circle. In this example, it was a hyperbola.